Let's suppose you write some code, you test it on your local laptop, everything looks fine, and now you push that code to GitHub. Now, how does this code actually reach from GitHub to production? Because between this GitHub and production, there are a lot of things happening in the pipeline. So let's understand the full journey step by step. Now, the first thing is obviously your code is sitting in the GitHub. So a developer raises a pull request and it gets reviewed and merged into main branch. Now the moment this code is merged into main, we don't want someone to manually say, now build the application, now run the test, and now deploy it. We want a system to do this automatically, and that is where CI comes in. CI basically means whenever a code changes comes in, we automatically build it and run checks on it. Build means preparing your application so that it can actually run. Checks can be things like unit test, integration test, security scans, and code quality checks. Now you might be thinking, okay, where all this actually is running? Because your CI pipeline is just instructions. Something still need to execute those instructions, and that is where a runner comes in. Runner is a virtual machine that execute those instructions. GitHub can give you a hosted runner for your job, or your company run its own machine, and that we call a self-hosted runner. For example, if you need access to some private infrastructure, you may keep that runner inside your own network. Now the runner start doing the real work. First, we build the application, then we perform security scans, then we test the code quality. And let's suppose one of these checks fail. Then what will happen? Obviously, we stop there. Why would we send something to production that is broken? So failed check stops the pipeline right there and nothing gets promoted further. But let's suppose everything passes and now we have a different problem. We have tested our code, but what exactly are we going to deploy? Are we going to take this source code and give it directly to production? Of course not. We first turn it to something that can be actually be deployed, and that is called artifact. Basically, an artifact is the finished package produced by our build that is ready to be deployed. For a Java application, this could be a jar file. For a containerized application, this could be a Docker image. So don't think artifact as some complicated thing. It is basically a built output that we are going to deploy. Now let's take example of Docker. We take our application, its dependencies, its runtime, and package it all into a Docker image. Now instead of giving the source code to production, we give this already built image to production. Now this image has something called as digest. Basically, it is a unique identifier for that exact image. So instead of saying give me the latest image, we can say give me the image with this exact digest. Now we have this image, but where do we keep it? We need some kind of central place from where different environments can get this image. Think of it like GitHub, but instead of storing your source code, it stores your container images. So our CI pipeline builds the image and pushes that image into container registry. And here is the important part. We don't build this image again for staging, and we don't build this again for production. Same image move further. Why? Because imagine you tested one image in staging, then production build the another image with same source code. How do you know they are actually identical? You don't know. So we build once, then move the same image through the different environments. Now you might ask, if the image is same, then what can change in development and production? The configuration. For example, the development may connect it to the development database and production may connect it to the production database. You can also have different environment variables, API endpoints, feature flags, and secrets. The application package stays the same. The environment specific configuration changes. And secrets should stay outside the image and can be provided securely at the runtime. Okay, so now we have tested the image. Now the image is sitting into our registry. Now who is going to take this image and actually deploy it? This is where CD comes in. CD means continuous delivery. In simple words, this is the process of taking the artifact and move it towards the production. For example, GitHub Actions can build the image, and we have something called as Argo CD that can handle the Kubernetes deployments. So the tool that build your application does not need to be the tool that deploy your application. Now this image move through the environments, maybe development, maybe staging. It depends on the company. After deployment, we run simple checks. Is the service running? Is the important endpoints are responding? And these are called smoke tests. If they fail, we stop. If they pass, we move forward. Now everything looks good. Smoke test passed, but before production, many teams have something called as production gate. Maybe someone need to approve it. Maybe there can be security or policy checks. If it's rejected, it never touches the production. But if it is approved, then we need to decide how we release. We don't have to replace everything at once. We have different deployment strategies. Rolling replace the old instances gradually. In blue-green, we keep two versions running. One is old and one is new. And we move the traffic to new one. and if something goes wrong, we switch back to old one. In canary, we send it to the small portion of traffic. If everything looks good, then we increase the traffic. If something goes wrong, that small portion of traffic is affected, not all. Now the new version is in the production, but succeeding the deployment does not mean the application is healthy. So we watch the real production signals like error rate, throughput, latency, and even business metrics. Now let's suppose the new version is causing some problem. Then we don't go back to Git and rebuild everything. We already have that previous release, so we deploy that good release again. Because it is already exists in the registry, that is what makes rollback much faster. Of course, database migrations can make the rollback complicated because the old version might not be compatible with the new schema. So now if you look at the complete flow, one code change comes in, we validate, we create an artifact which is deployable, then we store it, then we release it, then we watch production. If something goes wrong, we know what exactly we need to do, that is rollback. So don't think CI/CD as just a tool like GitHub Actions. Think of it as a journey of one code change.